This is an installation of cooling water pumps in front of a cooling tower. From cooling tower side, this is the isolation butterfly valve. Then this is the pipe spool for conical strainer. Then cooling water comes to pump suction. Inside this 36-inch pipe spool, conical strainer is there like this. For cleaning the conical strainer, entire spool need not be removed. One 12-inch handhole is provided on this side and another 12-inch handhole on other side, through which strainer surface can be cleaned and all debris will be drained through this 3-inch bottom flange connection. This is the 36-inch conical strainer which was installed inside the pipe spool of pump suction line. But when the first cooling water pump was started, after 30 minutes the conical strainer collapsed. Now you can see the damaged conical strainer inside the pipe spool. Now you can see the entire damaged conical strainer. Let us see the reason of such damage of the conical strainer. Now, for a conical strainer, two important parameters are there. Number one is available open area of the strainer and number two is collapse pressure retaining capability. Suppose this is the conical strainer, flow is from this side. This side is cooling tower and this side is the pump suction. This is pipe diameter. So, cross-sectional area of pipeline is pi d square by 4 and gross area of this cone or conical strainer is pi r L. L is the slant length of the strainer. Now, the conical strainer is having two things. One is this perforated sheet. These are the perforation. This perforation means about 6 dia holes at 9 pitch, like this. These are the 6 dia holes and 9 pitch means from this hole center to this hole center is 9 millimeter. And over this perforated sheet, screen is there or mesh is there. Say this is the wear mesh. Now, what will be the open area of this cone? For this perforated sheet or perforation, about 50% open area will be there and 50% area is blocked. And for this screen or wear mesh, about 50% area will be open and 50% area will be blocked. So, net open area of the strainer will be the surface area of the strainer pi r L into 50% opening due to this perforated sheet and another 50% opening due to the wear mesh or screen. Now you can see this is the perforated cone having perforated holes and this is the stainless steel wear mesh which is wrapped over the perforated cone. As per good engineering practice, this net open area of the strainer should be 2 times of cross-sectional area of pipeline. If cross-sectional area of pipeline and strainer open area is same, that means this open area and this pipe cross-sectional area is same, then actually when we use the conical strainer, at first use it becomes clogged. Some clogging will always be there. So it is assumed that 50% clogging will be there. That's why open area means net open area of the strainer should be minimum 2 times of pipe cross sectional area. This is picture of a strainer at 50% clogged condition. Now for a strainer, open area ratio means available open area of strainer divided by pipe cross sectional area, and open area ratio should be always greater than equals to 2. That means net open area of the strainer should be minimum 2 times of pipe cross sectional area. And this perforated sheet is of stainless steel, and thickness of this perforated sheet is usually 2 millimeter. It is not more than 2 millimeter or 3 millimeter, because it will be difficult to make the perforation on more thick SS plate. And this wear mesh can be of 20 mesh, 40 mesh or 100 mesh according to filtration requirement. Now coming to second point, collapse pressure retaining capability. When the strainer is clogged, means 100% clogged, suppose this side cooling tower is there, this side cooling tower is there, and in this side 5-meter water head is there, 5-meter, and this side pump suction is there, pump is sucking. If in this side water head is 5-meter water column, and in this side pump's required NPSH is 5-meter water column, then this side is positive pressure 5-meter water column, and this side is negative pressure of 5-meter water column. So 10-meter water column acts over this strainer, external force of 10-meter water column. That means 1 kg per centimeter square pressure. So strainer should be well capable enough to withstand this 10-meter water column of differential pressure, or 1 kg per centimeter square, or 1 bar of differential pressure. Up to 10-inch size, the rigidity of the strainer means rigidity of this 2 mm thick perforated sheet is sufficient against the collapsing. But above 10 inch, if the strainer size is 16 inch, 24 inch or 36 inch, then it requires stiffening to prevent collapsing of the strainer. Stiffening means we have to provide stiffeners like this inside the strainer. This is stiffener flat like this. This is one stiffener flat this side. This is another stiffener flat this side. These are welded inside the perforated sheet of the strainer. So these are two, and here actually another two. So inside of strainer we are providing 4 stiffener flats. These are 30 by 10 mm thick. 4 stiffener flats of 30 mm wide by 4 thick we are providing to prevent the collapsing. And for retaining the stiffener flats, we are providing one or two stiffener rings inside the strainer like this. This stiffener ring is of 12 mm to 16 mm stainless steel rod, and this stiffener flat is of 30 mm wide by 10 thick SS flat. And another stiffener ring, say like this. These stiffener rings are of about 12 to 16 mm dia SS rod. So these 4 stiffener flats are welded inside the SS perforated sheet, and 1 or 2 stiffener rings are welded over the perforated sheet to prevent the collapsing of the strainer. And since this side diameter is more, so this first stiffener ring should be provided at a distance of about 250 millimeter. Then next stiffener ring at a distance of about say 350 millimeter, like that. If we provide this type of 4 stiffener flats and 1 or 2 stiffener rings depending on strainer length, then at 100% clogged condition also, this strainer will be capable to withstand the collapse pressure. Now you can understand why this 36-inch cooling water pump suction strainer was collapsed and strainer shape has been changed like this. This is the originally supplied 36-inch conical strainer. There is no stiffener inside the strainer to protect it from collapse pressure. Strainer vendor has provided this type of stainless steel band outside the strainer to hold the wear mesh, but there is no protection from inside to prevent collapsing of the strainer due to external pressure. That's why the strainer has been collapsed. Now you can see that stiffeners have been provided on strainer inside to protect the strainer from collapsing. These are longitudinal stiffener flats and circular stiffener rings which have been welded with strainer's perforated sheet inside.